Quickly, we will start the fifth module, that is called two-port networks. As the examination point of view, this chapter is easy and I hope you don't lose marks from this topic. Alright, so let us introduce what do you mean by two-port network. Later, if time permits, we will solve two problems. The topic name is two-port networks. In the module, along with this topic, the resonance is added. So we will finish this two-port network by taking 3 to 4 or 4 to 5 classes. Once it is completed means we will go for the resonance. So in this two-port network, we will cover what do you mean by Z parameters, Y parameters, H and T parameters. Transmission line parameters are A, B, C, D parameters. These 4 parameters will be discussed and we will solve the problems on each parameters. And finally, at the end, we will see the relationship between all these parameters, that is Z parameters in terms of Y parameters, Z parameters in terms of H, T and so on. All possible combinations will be discussed at the end of the topic, right? So what are the objectives of this module? To understand about the two-port networks and its functions, to understand the differences between Z parameters, Y parameters, H parameters and T parameters. The third objective, to investigate and analyze the behavior of the two-port networks. These 3 are the objectives of this module. Let us see what do you mean by two-port networks. Before that, let us see what do you mean by port. A pair of terminals through which a current may enter or leave a network is known as a port here. It is a pair of terminal. Port means there we do find 2 terminals. A port means a pair of terminals. Keep the point in your mind. A terminal. A pair means 2. There are 2 terminals in one port. A pair of terminals through which current may leave or current may enter in a network, that is called as a port here. 2 terminal devices or elements results in one port network. You can see here, if we do find 2 terminals, then that is called as one port network. Our discussion is a 2-port network. That means there must be 4 terminals, because 2 terminals will form one port, but we are discussing about a 2-port here. We are discussing about a 2-port, then there must be 4 terminals. Alright. The most of the circuits have dealt with so far 2 terminals or one port and circuits, but actually it is not our discussion. Our discussion is 2-port circuits. Our discussion is 2-port circuits. Let us visualize. The 2-port network is an electric network with 2 separate ports for inputs and outputs. Hope you have got the meaning of a 2-port network here. 2-port network is having 4 terminals, in which 2 terminals are for input or 2 more terminals are for output, or else one port is for input, another port is for the output. So the 2-port network has 4 terminals or 2 ports. So each port has 2 terminals. It is 2 port, so that there will be 4 terminals. Out of these 4 terminals, 2 terminals are used for input purpose, 2 more terminals are used for output purpose. One more name. One port is used for input, another port is for output. It has 2 terminal pairs. You can see here one more name. two terminal pairs means it has two pairs, each of two terminals, then obviously it is four terminal. It can be called as four terminal device or four terminal network. One more name, two terminal pairs. Pair means two. Here there are two. Again there will be a four terminals. It has two terminal pairs acting as access points. The current entering one terminal of the pair leaves the other terminal in the pair. You will see the meaning of this with the help of a diagram. We can see here these two are called as terminals and it is called as one port. One port means there should be two terminals. It is first terminal and it is second terminal. So here current is leaving from the one terminal and the same current is leaving from the another terminal. That's why it is called as a one port network. In this linear network we can find the combinations of R, L, C or even independent and dependent sources. Probably the dependent sources, not independent sources. In a linear network, we will find R, L, C and dependent sources. Alright, you can see the meaning of two-port network. The two-port network has two-port network has four terminals. So two terminals are used in the input side. Two more terminals are used at the output side. So it is first terminal, second one, third one, fourth one. So combination of these two will make one port. Combination of these two will make one port. So totally we do find two ports here. That's why it is called as a two-port network. A pair of terminals or one port is used for input purpose. Another pair of terminals or one port can be used for output purpose. In this linear network we will find the combination of R, L, C and dependent sources. So the reason why to study the two-port networks. So such networks are useful in communication, control system, power system and electronics. Knowing the parameters of two-port networks enable us to treat it as a black box when embedded within the larger networks. That's why we need to study the two-port networks here. So from the network we can observe that there are four variables, that is I1, I2, V1, V2. We can see here which two are independent. We can see here in this we do find four it's not our point of discussion, actually it's our point of discussion. So in this we will find four parameters here, I1, V1, I2, V2. In the four terminal network or a two-port network there will be four parameters that is said here, which are two are independent. The various terms that relates these voltages and currents are called as a parameters here. So these variables are called in general as a parameters. Alright, so parameters, they are I1, I2, V1 and V2. These are the parameters. These parameters are studied with respect to Z parameters. Z means here impedance parameters. Impedance parameters means, so the impedance is expressed in terms of these parameters. I repeat, impedance of a two-port network is defined in terms of these parameters. You should understand what you mean by here parameters. Parameters means these variables I1, I2, V1, V2. Z parameters, the impedance is expressed, defined in terms of parameters. Impedance is expressed in terms of I1, I2, V1 and V2. That's why it is called as a Z parameters. Z parameters are also called as impedance parameters, and the unit is ohm. Alright. Impedance parameters is commonly used in the synthesis of the filters and also useful in the design and analysis of the impedance matching networks and power distribution networks. The use of the Z parameters here. The two-port network may be voltage driven or current driven. So two-port network we have seen, this is the two-port network. It is the two-port network. Here port 1, here it is terminal 1, terminal 2, terminal 3, terminal 4, or else it is called as a port 1 and it is called as a port 2. Here I1 current enters, I1 current leaves. Here I2 current enters, I2 current leaves. Alright. Next thing is, so two-port network may be driven by, it may be driven by a voltage or current. So you can see here it is a network where we will find the combination of RLC and dependent sources, and it is driven by voltage source here. It is a two-port network. Here it is two-port network and it is driven by the voltage source. The same thing, here it is a two-port network but it is driven by the current source. Hope you have got the meaning of the two-port network driven by voltage source and the current source. Alright, the black box, here it is a black box here, this one. Here we will find the combinations, it may be series, parallel, or series, parallel, star, delta. So all combinations of RLC can be observed in this black box. Is replaced with the Z parameters is shown below here. Alright, so the linear combinations of RLC can be replaced by, here it is Z11, Z12, Z21 and Z22. The terminal voltages can be related to the terminal currents as terminal voltages. Here it is V1, terminal currents I1 and I2. Terminal voltages are V1 and V2. Terminal currents are I1 and I2. In port 1, I1 current leaves. From the second terminal, same I1 current leaves. So in port 2, I2 current enters and same I2 current leaves from the fourth terminal. This is what the expression for the Z parameters. It should be remembered very properly. So the Z parameters, the terminal voltages are V1 and V2. They can be related with the help of terminal currents I1 and I2 using this expression. The terminal voltage V1 can be written as Z11 into I1 plus Z12 into I2. V2 equals to Z21 into I1 plus Z22 into I2. These two equations should be remembered very properly. So all derivations, all problems will depend on these two equations. So V1, I repeat, V1 equals to Z11 into I1 plus Z12 into I2. V2 equals to Z21 into I1 plus Z22 into I2. Alright. So the same these two equations, that is V1 equals to Z11 I1 plus Z12 I2. V2 equals to Z21 I1 plus Z22 into I2. So these two equations are represented in a matrix form. We know that these two are the simultaneous equations. So these two equations can be represented in matrix form. V1, V2, Z11, Z21, Z21, Z22 and I1 and I2. So here V1 and V2 are, so terminal voltages, I1 and I2 are the terminal currents, Z1 and Z21, Z21 and Z22. They are called as a impedance parameters. Alright. So Z parameters that we want to determine, then what do you mean by Z11, Z12, Z21 and Z22? That is our point of discussion here. So simply we have said these values, then what do you mean by these parameters? Alright, the value of the parameters can be evaluated by setting I1 equals to 0. We will get the first two parameters Z11 and Z21, and to calculate the values of Z12 and Z22, make I2 as 0. Alright, okay, so the meaning of this is to calculate Z11 and Z21 in the two-port network, make I1 as 0. What do you mean by I1 is 0? I1 is 0 means it is 0 amperes. Somewhere we do find open circuit. So I1 is this input current, so that we are making input port as open circuit. That is the meaning of it. So Z11 and two parameters can be calculated by making input port as an open circuit. Then two more parameters can be calculated by making output port as a open circuited here. The meaning of this I2 is equal to 0. I2 is 0 means here it is 0 amperes. So 0 amperes can be written as open circuit. So I2 is it nothing but the output port. So we are making output port as a open circuited, so that we will get the values of two more parameters. Alright. So here it is. So we will get, we do have V1 equals to Z11 I1 plus Z12 I2, V2 equals to Z21 I1 plus Z22 I2. These two are the standard equations. So in this equation, let us make input port current as 0. Input port current as 0 means it is open circuited. Input port is open circuited. At that time, what happens here? Wherever I1 is there, substitute. What will get? V1 equals to, this term is 0 plus Z12 into I2. So from second equation, V2 equals to, this term is 0, Z22 into I2. So that we do simplify here. We do simplify. What is V1? V1, what is Z12? Z12 is equals to, okay. So if input ports is done, we will get V1 equals to Z12 into I2. What is Z12? Where is that? Z12 is here, and it is the ratio of V1 divided by I2. The condition is the input current is made 0. So from this equation, what is Z22? Z22 equals to V2 divided by I2. Here it is there. Z22 equals to V2 divided by I2. The condition is I1 is made open circuited. Alright, let us make I2 as 0. What is the meaning of this I2 as 0? The output port is open circuited. The output port is open circuited. If that is the case, means what happens? Substitute I2 equals to 0 in equation number 1 and 2. So what we'll get? So this term is 0. We will get V1 equals to Z11 into I1. So that you can see here, what is Z11? Z11 equals to V1 divided by I. That is written here. Z11 equals to V1 divided by I1. The condition is the output port is open circuited. Alright. Then substitute I2 is equals to 0 in equation number 2. So that this term is 0. So Z21 equals to V2 divided by I1. That is there. Z21 equals to V2 divided by I1. The condition is the output port or output terminals are open circuited. So that they are called, what is Z11 here? Open circuit input impedance. Z11 can be named as open circuit input impedance. You can see here. So it is an impedance at the input side. It is obtained because of output circuit is open. What is Z12? Open circuit transfer impedance from port 1 to port 2. You can see here the meaning of this subscript. It is the transfer impedance from port 1 to port 2, and it is also called reverse transfer impedance. You should know the naming of these Z parameters. Z11 is called as, in simple, open circuit impedance, input impedance. Z12 is called as a reverse transfer impedance, or else open circuit transfer impedance from port 1 to port 2. Then we will see what do you mean by Z21. Z21 is called as this one. Z21 is called as open circuit transfer impedance from port 2 to port 1. It is called as open circuit transfer impedance from port 2 to port 1. And it is also called as forward transfer impedance. Z12 is called as a reverse transfer impedance. Z21 is called as a forward transfer impedance. What is this Z22? You can see here. Z22 is called as a open circuit output impedance. It is called as Z22. It is called as open circuit output impedance. Alright? Good. So we can see here open circuit impedance or Z parameters. They are one and the same. Just we revise. So these are the equations. Should be remembered. It is its matrix form, and Z impedance parameters is represented in a matrix form. It is called as impedance matrix. And here the input driven point impedance Z11 equals to V1 divided by I1. The condition is I2 is 0. The meaning of this is output port is open circuited. The reverse transfer impedance Z12. The definition of this is V1 by I2. The condition is I1 is made 0. The meaning of this is the input port is open circuited, and they are measured in terms of units. The third parameter, forward transfer impedance. It can be defined Z2 by I1 by setting I2 equals to 0. The last parameter, output driven point impedance. Z22 equals to V2 by I2, so that I1 equals to 0. The meaning of this is input circuit is open. Alright, so all these parameters are measured in terms of ohms. And it is important here, after every problems, you should draw the equivalent circuit using Z parameters. It is just a factorization of the defined equations. This is what here the equivalent circuit of this two-port network. You can see here, this is the two-port network. It is the two-port network. Here it is, we'll find I2. Here we'll find the I1, and here it is V1, and here it is V2, and here two-port network. Alright, so V1 is what? We can write the equations here. V1 equals to Z11 I1 plus Z12 I2. V2 equals to Z21 I1 plus Z22 I2. And I will write Z11 equals to V1 by I1. Z21 equals to V2 by I2, V2 by I1. Z12 equals to V1 by I2. Z22 equals to V2 by I2. No need to remember all these equations. You just to get the value of Z11, substitute I2 is equals to 0. So if this is 0 means Z11 equals to V1 by I1. No need to remember. From these equations, these formula should be written. Alright. So this is what the equivalent circuit for this two-port network here. Alright. So if you apply KVL to this mesh, can we get this equation? We can see here. So here it is minus, it is plus, and here the current I1 is flowing, and here voltage dependent voltage source is written here. Voltage dependent voltage source is written. So if you apply KVL to this, what will get? Minus V1 plus I1 Z11 plus I2 Z12, that is equals to 0. To simplify this, V1 equals to Z11 I1 plus Z12 I2. You can see here they are one and the same. This equation and this equation, they are one and the same. So it is obtained by applying KVL to this complete mesh. So we do find 3 voltages here, 1, 2, 3, and it is voltage dependent voltage source. You can see here minus, plus, and plus. To simplify, we will get. That's why it is called as equivalent circuit at input port. Later, it is the equivalent circuit at the output port, and it is expressed Z22, and it is voltage dependent voltage source. Again, apply the KVL for this mesh. Minus V2 plus I2 into Z22 plus what is the voltage of this? Z21 into I1. Alright, to simplify, V2 equals to Z22 into I1 plus Z21 into I1. So that these two equations are one and the same. So it is written as independent source. Sorry, it is written as dependent source because its value depends on current I2. Current I2 is available at the output side. It is written as dependent source because its value depends on I1 current, but I1 current is taken from input side. That's why in an input circuit, this voltage depends on the output current. That's why it is called as a dependent source here. It is written as a dependent source because its value depends on the current I1, and this current I1 is taken from the input port. Good. So, conditions for reciprocity. When do you say that the circuit is reciprocal? The condition is it should be satisfied. If Z12 is equals to Z21, then you can say that the given network is reciprocal in nature. Alright, so they do say calculate the Z parameters of the network and identify whether the circuit is reciprocal or not. After calculating Z12 and Z21, if they are equal, then you can say that the circuit is reciprocal in nature. Keep this point in your mind. Next condition. Condition for symmetry. The two-port network is said to be symmetrical if its ports can be interchanged without changing the port voltages and the current. That is called as a symmetrical network. I repeat, a two-port network is said to be symmetrical if its port can be interchanged without changing the port voltage and the currents. Then what is the condition for this? So if Z11 equals to Z22, then you can say that a given network is symmetrical in nature. Alright, you should remember. So Z12 equals to Z22, then that is called as a reciprocal network. Z11 equals to Z22, then you can say that the given network is symmetrical in nature. So that it is the equivalent circuit of a two-port networks. You should keep that in your mind. So it is port 1, it has 2 terminals. It is port 2, it has 2 terminals, total 4 terminals, and it is the equivalent. It is the equivalent circuit of a or network of a given network in terms of Z parameters.